Last two speakers you heard, Larry gave a talk on a pair of coordinated satellite measurements called Atmospheric or Electrodynamics Explorer. NASA is also investing a fair amount of money in a program called IME, which is again a double or a triple set of probes to. Excuse me, right. This again is an attempt to make coordinated measurements with multiple probes in an attempt to do one of the things that really needs to be done quite well, and that is separate spatial and temporal features in the phenomenon we're looking at. And I would like to talk to you about a rather fortuitous set of circumstances that have the possibility of occurring right in the middle of the IMS period, and something a program office such as Fred Reese just mentioned could contribute a great deal to, in the sense that it requires very little money. It just requires a good deal of cooperation out of NASA headquarters and the ATS project office. The situation is with the ESRO satellite GEOS and ATS. And if I could just take your time to run through a few dates here. ATS is going to be launched this coming April and will stay at 95 degrees or 94 degrees west for 1 year, and will begin then in April 75 to move toward 30 degrees east longitude, and will arrive there in something like July of 75, and is presently scheduled to remain there until July of 76. The GEOS satellite, this is ATS, is presently scheduled to be launched in August or September of 76, and will be positioned at, due to the hope for and correlation with ATS, they have set their shift plan up to correspond with ATS such that they will go to 35 degrees west initially and begin, as soon as they stabilize the spacecraft, a 1 degree per day shift to 30 degrees east, arriving something like January 1st, 1977. This, in effect, is right in the middle of the IMS period. Now, just look what this really does if you follow through on this. At the end of this period, ATS is supposed to go back to something like 104 degrees and arrive over the U.S. In something like November of 77. If, however, we can keep ATS at 30 degrees east until GEOS arrives in January of 77, we have the following thing that will happen. You can think of this as L of 6.6. ATS initially starts out over here at 95 degrees west, and then will be taken to 35 degrees east. When GEOS is launched, it'll be at 30 degrees west. It will begin a move toward this position, arriving, as I said, January 77, and coming to within 5 degrees of the, this is 35, excuse me. Arriving within 5 degrees of the ATS position. This field line, depending on whose model you use, maps right down into northern Scandinavia. And as Fred mentioned, the Europeans are very well organized already. 2 meridional magnetometer chains, a 100 kilometer by 100 kilometer 20 magnetometer chain network, complete all-sky camera, many goniometers in this region of northern Scandinavia. So there's an awful lot of potential physics that can be done with 2 spacecraft that close together, a rocket range which probably will sit right in the middle of them, and a complete ground-based network. Then we can allow, if the ATS project cooperates, holds ATS there until January, and then takes it back to 104 degrees west. It will then start and move back over some 3 or 4 month time period. So in effect, what we have is a mother-daughter mission at geostationary satellite in a rather fortuitous set of circumstances, if this can be brought about. In other words, we start out with 4 hours of local time, approximately, separation. We close down to a matter of minutes, can cross-calibrate the two spacecraft, and then allow a gradual separation to some 9 or 10 hours. And this really doesn't require any additional funding, doesn't require any additional satellites. The GEOS, there are at least 2 and possibly 3 experiments represented here today. And I would suggest that you might talk to these people, because it is an extremely well instrumented spacecraft. It has a 100 kilobit bit rate. It can do just about anything a spacecraft can do. So the potentials here are really quite unique, and the fact that they occur right in the middle of the IMS should give this program some real impetus. But it does require some cooperation from the ATS project, and it is an applications program, and science carries very little weight there, and so it's something that needs to be worked on. A committee such as a strong IMS U.S. National Committee could make, hopefully, an impact in such a problem. Thank you.